Download this code from codegive.com, link in the description below. Sure. Multithreading is a crucial concept in programming that allows multiple threads to run concurrently, thereby improving the performance of applications. In the context of coding interviews and platforms like LeetCode, multithreading problems often test your understanding of synchronization, race conditions, and inter-thread communication. Overview of common multithreading concepts. 1. Threads, the smallest unit of processing that can be scheduled by an operating system. 2. Synchronization, mechanisms to ensure that two or more concurrent threads do not simultaneously execute some code that could lead to inconsistent or incorrect results. 3. Locks, a way to enforce limits on access to a resource when multiple threads are trying to access it. 4. Condition variables, a synchronization primitive that allows threads to wait for certain conditions to become true. 5. Deadlock, a situation where two or more threads are blocked forever, each waiting on the other. Common patterns in multithreading problems. 1. Producer-consumer, one or more producers generate data and one or more consumers process it. 2. Dining philosophers, a classic synchronization problem involving resource sharing. 3. Print in order, ensuring that threads print in a specific order. Example problems. Here are a few examples of multithreading problems along with their solutions. 1. Print in order. Problem statement, given 3 threads, first, second, and third, you need to print first, second, and third in that order. Solution. Python. Import threading. Class print in order. Def __init__, self. Self.lock_first equals threading.lock. Self.lock_second equals threading.lock. Self.lock_first.acquire, start with the first thread unlocked. Self.lock_second.acquire, second thread locked initially. Def first, self, print first, callable, -none. Print first, Self.lock_first.release, allow the second thread to run. Def second, self, print second, callable, -none. Self.lock_first.acquire, wait for the first thread to finish. Print second, Self.lock_second.release, allow the third thread to run. Def third, self, print third, callable, -none. Self.lock_second.acquire, wait for the second thread to finish. Print third, 2. 0 even odd. Problem statement, implement a 0 even odd class with methods 0, even, and odd. The 0 method should print 0, and the even method should print even numbers up to n, while the odd method should print odd numbers up to n, ensuring that the numbers are printed in the correct order. Solution. Python. Import threading. Class 0 even odd. Def __init__, self, n, int. Self.n equals n. Self.lock_0 equals threading.lock. Self.lock_even equals threading.lock. Self.lock_odd equals threading.lock. Self.lock_even.acquire. Self.lock_odd.acquire. Def 0, self, print number, callable, -none. For I in range, self.n. Print number, 0. If I%2 equals 0. Self.lock_even.release. Else. Self.lock_odd.release. Def even, self, print number, callable, -none. For I in range, 2, self.n plus 1, 2. self.lock_even.acquire. Print number, I. Def odd, self, print number, callable, dash none. For I in range, 1, self.n+1, 2. Self.lock_odd.acquire. Print number, I. 3. The dining philosophers. Problem statement, 5 philosophers sit at a table and eat spaghetti. They need 2 forks to eat, and they must pick up the forks before eating. Ensure that they don't end up in a deadlock situation. Solution. Python. Import threading. Class dining philosophers. def__init__, self. Self.forks equals threading.lock, 4_ in range, 5. Def eat, self, index. Left_fork equals self.forks index. Right_fork equals self.forks, index +1, %5. To avoid deadlock, always pick the lower index fork first. If index %2 equals 0, even index philosopher. Left_fork.acquire. Right_fork.acquire. Else, odd index philosopher. Right_fork.acquire. Left_fork.acquire. Eat. Self.dine, index. Release forks. Left_fork.release. Right_fork.release. Def dine, self, index. Print, F philosopher index is eating. Def start_dining, self. Threads equals. For I in range, 5. T equals threading.thread, target equals self.eat, args equals I. Threads.append, T. T.start. For T in threads. T.join. Conclusion. These examples cover some fundamental multithreading problems you might encounter on LeetCode or similar platforms. Understanding how to synchronize access to shared resources and how to coordinate between threads is key to solving these problems effectively. Tips for practicing multithreading problems. 1. Understand the problem, always clarify what is required before writing any code. 2. Use locks wisely, avoid overusing locks, as they can lead to deadlocks if not managed properly. 3. Test for race conditions, make sure to test your code under different scenarios to catch any race conditions. 4. Be aware of performance, multithreading can introduce overhead, sometimes, the use of threads can degrade performance if not done correctly. Feel free to reach out if you have further questions or need additional examples.